10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift off normal.
P1 tracking.
P3 tracking.
Magnificent liftoff of PSLV C-57 with Aditya L1 on board.
Plus 15 seconds.
PSLV C-57 का सफल उत्थापन और इसके साथ
20 seconds.
प्रथम भारतीय सौर अंतरिक्ष यान निकल चुका है सूर्य के
Plus
तेज से
25
विज्ञान को प्रकाश करने।
Air lead strap on ignited.
इसके साथ ही
Plus
एक और
30
कदम
seconds.
है अंतर्ग्रहीय सफर में भारत की उपस्थिति सिद्ध करने का। आप देख रहे हैं PSLV C-57 प्रथम चरण पूरी तरह सामान्य।
The rocket flying forth, following nominal trajectory and developing nominal thrust. The bright fumes against a clear midday sky. A rocket launch is more than just a sight to behold. The roaring sound and the vibrations that we can feel here, adding to this, the thrill are just amazing. Ground lit and air lit strap-ons operating together with the first stage S-139.
Ground lead strap on separated.
जैसा कि निर्धारित है ग्राउंड लेड स्ट्रैप ऑन को सेपरेट कर दिया गया है
Normal.
और प्रथम चरण का निष्पादन सामान्य है। इस घटनाक्रम में अगला एयर लेड स्ट्रैप ऑन को यान से पृथक कर दिया जाएगा।
Air lead strap on separated.
जी हाँ, इसकी भी पुष्टि हो गई है। स्ट्रैप ऑन को सफलतापूर्वक पृथक कर दिया गया है।
We are 100 seconds past the launch time. The ground lit and air lit strap-ons have been separated. S-139 motor still thrusting.
S-139 110 सेकंड के प्रज्वलन काल के पश्चात उसे भी पृथक कर दिया गया है।
Plus 2 minutes.
द्वितीय चरण जो कि तरल नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है और वर्तमान में प्रणोद उत्पन्न कर रहा है।
Normal.
The launch vehicle is at an altitude of 73 kilometers. First stage has been separated. Second stage has begun its operation and the closed loop guidance has been initiated. According to the announcement by Range Operations Director, PS2 is developing nominal thrust.
PS2 41 टन के तरल नोदक पर आधारित चरण है। इसमें विकास इंजन द्वारा 800 किलो न्यूटन का प्रणोद उत्पन्न होता है और इसका प्रज्वलन काल लगभग 150 सेकंड का होगा।
Shar and Port Blair tracking stations presently acquiring signals. Flight path closely matching the prediction.
Plus 3 minutes.
वर्तमान में यान क्लोज लूप गाइडेंस के अंतर्गत है।
Second stage performance normal.
यान की ऊंचाई 106 किलोमीटर तथा सापेक्ष गति 3 किलोमीटर प्रति सेकंड।
The velocity addition in PS2 regime is going to be from 2 kilometers per second to 4.9 kilometers per second.
Payload fairing separated.
The payload fairing covering the Aditya L1 spacecraft has been separated. The current altitude of the launch vehicle is 118 kilometers. Relative velocity exceeding 3.8 kilometers per second.
जी हाँ, यान अब घने वातावरण से बाहर जा चुका है, इसलिए ऊष्मा कवच की जरूरत नहीं रह जाती है और इस कारण इसे यान से पृथक कर दिया जाता है।
Second stage performance normal.
द्वितीय चरण वर्तमान में प्रणोद उत्पन्न करता हुआ और यान पूरी तरह सामान्य प्रदर्शन करता हुआ अपने अनुमानित पथ की ओर बढ़ रहा है।
Second stage separated. Third stage ignited.
द्वितीय चरण को भी सफलतापूर्वक यान से पृथक कर दिया गया है उसके प्रज्वलन काल समाप्त होने पर।
Normal.
और तृतीय चरण जो कि ठोस नोदक पर आधारित चरण है, इसका प्रज्वलन शुरू हो चुका है।
We are close to 5 minutes past the launch time. Presently, the third stage of PSLV is operational, developing nominal thrust.
Plus 5 minutes.
तृतीय चरण में 7.6 टन के ठोस नोदक का प्रयोग होता है और इसका प्रज्वलन काल 117.7 सेकंड का होगा। इस दौरान यह 240 किलो न्यूटन का प्रणोद उत्पन्न करेगा। वर्तमान में यान की ऊंचाई 134 किलोमीटर तथा सापेक्ष गति 5.96 किलोमीटर प्रति सेकंड। जैसा कि हम जानते हैं पीएसएलवी सबसे विश्वसनीय रॉकेट रहा है इसरो का, वैसा ही प्रदर्शन करता हुआ एक और मिशन पीएसएलवी C-57 का
For the present mission, after PS3 completes
Plus
its
6
burn
minutes.
duration, a coast phase of 200 seconds will follow, in which the rocket will continue to be steered while there is no development of thrust.
जी हाँ, अभी कुछ ही क्षणों में
Third
PS3
stage
का
action completed.
प्रज्वलन काल समाप्त हो चुका है और कोस्टिंग फेज इसके बाद जारी रहेगा।
Vehicle in combined hosting for approximately 200 seconds.
Unique to this mission, the
Vehicle
PS4
performance normal.
will start twice at predesignated times
Plus
and
7
duration.
minutes.
The multiple start capability of PS4 will be utilized very aptly to achieve the argument of perigee of 346.6 degrees, which is very crucial for this mission. The commencement and duration of PS4 burns enable achieving this orbital parameter. Argument of perigee is the angle that is made by the perigee point from the ascending node at equatorial plane. AOP exceeding 300 degrees is helpful in mission planning to achieve halo orbit around L1 with minimal propellant expenditure.
सभी वैज्ञानिक गहनता से अध्ययन करते हुए इन आंकड़ों का, जो कि ग्राउंड स्टेशन द्वारा प्रसारित किए जा रहे हैं। वर्तमान में PS3, PS4 कंबाइंड कोस्टिंग फेज जारी है। यान की ऊंचाई 170 किलोमीटर तथा सापेक्ष गति 7.32 किलोमीटर प्रति सेकंड है।
Vehicle performance normal.
Plus 9 minutes.
Speaking a few words about the Aditya L1, describing the sun, Indian Vedas have said, Yesha Bhagavan Manirakasha Mandalasya Chakravarti Khechara Chakrasya Deepako Brahmanda Bhandasya Asayeva Charkarti Bharvati Jarhati Jagat. This mighty jewel, the light of eastern sky, who generates, operates and destroys the universe, while the energy of sun, after having filtered by the atmosphere, is available for the sustenance of earth. The explosive phenomena in sun and the solar flares are a cause for concern to the spacecraft and human space missions. The vantage point for such observations is a place in between the sun and earth.
Third stage separated.
Now we have a successful separation event of the third stage of
Separated
PSLV.
hosting, it is approximately 900 seconds.
Plus 10 minutes.
जी हाँ, तृतीय चरण को सफलतापूर्वक
Still
पृथक कर दिया
performance
गया है
normal.
और अब PS4 कोस्टिंग फेज पर है। इस दौरान कोई भी प्रणोद उत्पन्न नहीं हो रहा है। यान प्राप्त संवेग से आगे बढ़ता हुआ और निर्धारित पथ का अनुकरण करता हुआ जा रहा है।
We are 627 seconds from the launch. For another 600 more seconds or so, we will be getting tracking data from the BIAX ground station.
यह कोस्टिंग फेज लगभग 900 सेकंड का होगा। इस दौरान हम आपको कुछ जानकारी देते हैं। लैग्रेंज पॉइंट से जुड़ी कुछ रोचक तथ्य भी हैं, जैसे कि इस पॉइंट का नाम एक इटालियन फ्रेंच गणितज्ञ जोसेफ लुइग लैग्रेंज के सम्मान में रखा गया था। उन्होंने 1972 में इसे अपनी तकनीकी प्रपत्र जनरल 3 बॉडी प्रॉब्लम में वर्णित किया है, लेकिन इससे पहले भी 3 पॉइंट L1, L2 और L3 को खोजने का श्रेय स्विस गणितज्ञ लेनार्ड आयलर को जाता है। L1 पॉइंट पर नासा ने पहले ही सोलर एंड हेलियोस्फेरिक ऑब्जर्वेटरी सोहो को पहुंचा चुका है और विश्व प्रसिद्ध जेम्स वेब टेलीस्कोप को L2 लैग्रेंज पॉइंट पर स्थापित किया गया है। L1 की पृथ्वी से सूर्य की दिशा में दूरी लगभग 15 लाख किलोमीटर है और इसे हम एस्ट्रोनॉमिकल यूनिट में 0.01 एस्ट्रोनॉमिकल यूनिट कह सकते हैं। यह पृथ्वी से सूरज की दूरी का केवल 1% है।
The vantage point for observing sun is a place in between the sun and earth where direct visibility exists to the sun while continuous communication link exists with the earth. These observations will generate a forewarning about disturbances in near earth space environment which could pose danger to the communication systems and spacecrafts. Various thermal and magnetic phenomena on the sun are of extreme nature which cannot be replicated in labs. The best way is to observe the sun up close. The distance between the Earth and Sun is approximately 150 million kilometers. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. Power source for the Sun is nuclear fusion of hydrogen atoms that takes place in the core. The visible surface of Sun is relatively cool and has a temperature of about 5,500 degrees Celsius. The Aditya L1 spacecraft is planned to be placed in a halo orbit around the Lagrangian point
Vehicle
1
performance
or
normal.
L1 of the Sun-Earth system, which is about 1.5 million kilometers from Earth, roughly 1% of the distance to Sun. A halo orbit is a periodic three-dimensional orbit near the Lagrange point in the three-body problem of orbital mechanism. The object in this orbit stays in place by the gravity of Earth and Sun. It requires little energy for station keeping. Several probes have been placed in space to observe the Sun by various space agencies. Lagrange's point L1 is a great location for solar explorers such as Aditya L1, as it allows for an unobstructed view of the Sun that is never eclipsed by Earth. At L1, Aditya L1 will join spacecraft such as ESA-NASA's Solar Heliospheric Observatory or SOHO, which has been at L1 since 1996.
लैग्रांज पॉइंट एक ऐसी जगह है अंतरिक्ष में जहां अगर कोई चीज़ पहुंचती है तो वह वहीं बनी रहती है, क्योंकि लैग्रांज पॉइंट पर दो बड़े द्रव्यमानों का गुरुत्वाकर्षण खिंचाव बराबर हो जाता है। और इसमें एक अभिकेंद्रीय बल है कि जो कि पिंड को दोनों द्रव्यमान के साथ बनाए रखता है। ऐसे 5 लैग्रेंजियन पॉइंट्स होते हैं पृथ्वी और सूर्य के बीच। इन पॉइंट्स में अंतरिक्ष यान को भेजकर कम से कम ईंधन की खपत पर या उस स्थान पर अंतरिक्ष प्रयोगों को अध्ययन के लिए बनाए रखा जा सकता है। आदित्य L1 उपग्रह को भी ऐसे ही लैग्रेंज पॉइंट 1 पर स्थापित किया जा रहा है। अंतरिक्ष यान को यहां तक पहुंचने में 125 दिन का समय लगेगा। इस लैग्रेंजियन पॉइंट्स के कुछ फायदे होते हैं, जैसे हम यहाँ आदित्य L1 के बारे में बात कर रहे हैं तो यह अंतरिक्ष यान लैग्रेंजियन पॉइंट 1 के पास जाएगा और यहाँ ऐसा पॉइंट है जहाँ से सूर्य को बिना किसी ग्रहण या रुकावट के निरंतर देखा जा सकेगा और अध्ययन किया जा सकेगा। दूसरा फायदा यह कि विभिन्न मापन या विश्लेषणों के लिए किसी भी तरह की रुकावट या कमी नहीं आएगी। वायु न होने की वजह से इससे दूर तक स्पष्ट देखा जा सकेगा। लैग्रेंज पॉइंट पर इस वेधशाला को रखने का मुख्य कारण यह भी है कि यहाँ उपग्रह लगभग स्थिर रहेगा और उपग्रह के अभिवृत्ति नियंत्रण के लिए अधिक ईंधन की आवश्यकता नहीं होगी। वर्तमान में PS4 चरण का कोस्टिंग फेज जारी है। अब यान की ऊंचाई 280 किलोमीटर तथा सापेक्ष गति 7.18 किलोमीटर प्रति सेकंड है। अब यह उचित अभिवृत्ति प्राप्त कर पुनः प्रज्वलित किया जाएगा।
Vehicle performance normal.
The Aditya L1 spacecraft carries 7 payloads to observe the protosphere, chromosphere and corona, which is the outermost layer of the Sun. These payloads use electromagnetic, particle and magnetic field detectors. First among the 4 remote sensing payloads is Visible Emission Line Chronograph, VELC, which is a prime payload designed as a reflective coronagraph with a multi-slit spectrograph. This payload is developed jointly by Indian Institute of Astrophysics, Laboratory of Electro-Optical Systems, UR Rao Satellite Center, ISRO Inertial Systems Unit and Space Applications Center. The second payload is Solar Low Energy X-ray Spectrometer or SOLEX, designed to measure the solar soft X-ray flux to study solar flares. This payload is developed by UR Rao Satellite Center. Third payload is the Solar Earth Ultraviolet Imaging Telescope SUIT, which is a UV telescope to image the solar disk in the near ultraviolet wavelength range. The payload is developed by Inter-University Center for Astronomy and Astrophysics, Pune, LEOS, URSE and IISU. The fourth payload is High Energy L1 Orbiting X-ray Spectrometer or HELIOS, developed by URSE. Is a hard X-ray spectrometer designed to study solar flares in high energy X-rays. The fifth payload is the one which is meant for in situ observations. This is Aditya Solar Wind Particle Experiment, or otherwise called as ASPEX, which comprises of spectrometers to measure low energy particles and high energy ions. This payload is developed by Physical Research Laboratory. The sixth payload is Plasma Analyzer Package for Aditya, in short PAPA. It is designed to understand the solar winds and its composition and perform mass analysis of solar winds. This payload is developed by Vikram Sarabhai Space Center. The seventh payload is a magnetometer or MAG developed by LEOS, which will measure the low intensity interplanetary magnetic field in space using a pair of magnetic sensors.
जी हाँ, आदित्य L1 उपग्रह में निध भार के बारे में जानते हुए इसमें सुदूर संवेदन नितभार हैं और यथास्थिति प्रेक्षण नितभार लगे हुए हैं। सुदूर संवेदन नितभार में सूर्य का प्रेक्षण करने के लिए
Plus 20
VELC
minutes.
कोरोना प्रतिबिंबन और वर्णक्रम मापन के लिए है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप जो कि संकीर्ण और ब्रॉडबैंड फ्रीक्वेंसी में फोटोस्फीयर और क्रोमोस्फीयर प्रतिबिंबन यह पैराबैंगनी प्रतिबिंबन टेलीस्कोप है। इसी क्रम में अगला है SOLEX सोलर लो एनर्जी एक्सरे स्पेक्ट्रोमीटर जो कि सॉफ्ट एक्सरे वर्णक्रम मापी है जो कि सूर्य के प्रेक्षण के लिए प्रयोग किया जाएगा। इसमें HEL1OX हाई एनर्जी L1 ऑर्बिटिंग एक्सरे स्पेक्ट्रोमीटर है जो कि हार्ड एक्सरे वर्णक्रम मापी है। इसकी अभिकल्पना सोलर फ्लेयर के अध्ययन के लिए की गई है। यथास्थिति नितभार में आदित्य सोलर विंड पार्टिकल एक्सपेरिमेंट, इसका उद्देश्य है सोलर पवन सौर पवन में भारी आयंस, प्रोटॉन्स और अल्फा पार्टिकल का विश्लेषण करना। अगला है प्लाज्मा एनालाइजर पैकेज फॉर आदित्य। यह भी सौर पवन में उपस्थित कणों में इलेक्ट्रॉन और भारी आयंस की दिशा के साथ विश्लेषण करने के लिए इसे बनाया गया है। एडवांस ट्राइएक्सियल हाई रेजोल्यूशन डिजिटल मैग्नेटोमीटर, इसे त्रिअक्षीय चुंबकीय क्षेत्र के यथास्थिति मापन करने के लिए बनाया गया है और ऐसे 2 समुच्चय लगे हुए हैं इस उपग्रह में।
Vehicle performance normal.
यान पूरी तरह सामान्य, सभी तंत्र सामान्य रूप से कार्य कर रहे हैं और यान अपनी उद्देश्य कक्षा की ओर बढ़ रहा है। आदित्य L1 के नितभार इसरो व अन्य वैज्ञानिक संस्थानों के साथ मिलकर तैयार किए गए हैं। विजिबल एमिशन लाइन कोरोनोग्राफ VELC इंडियन इंस्टीट्यूट ऑफ एस्ट्रोफिजिक्स बेंगलुरु द्वारा तैयार किया गया है। सोलर अल्ट्रावायलेट इमेजिंग टेलीस्कोप सूट इंटर यूनिवर्सिटी सेंटर फॉर एस्ट्रोनॉमी एंड एस्ट्रोफिजिक्स पुणे द्वारा निर्मित है। सोलेक्स और हेलियोस दोनों ही UR सैटेलाइट सेंटर बेंगलुरु द्वारा निर्मित किए गए हैं। ASPX और PAPA स्पेस फिजिक्स लेबोरेटरी VSSC तिरुवनंतपुरम द्वारा निर्मित किए गए हैं। और अंत में मैग्नेटोमीटर लेबोरेटरी फॉर इलेक्ट्रो ऑप्टिक्स सिस्टम्स बेंगलुरु द्वारा निर्मित किया गया है। यह कोस्ट फेज जारी रहने वाला है। आइए इस अंतराल में आपको लिए चलते हैं इस मिशन से जुड़ी चर्चा में, जहां वरिष्ठ वैज्ञानिक हमारे प्रश्नों के उत्तर देंगे और फिर इस चर्चा के बाद हम वापस आएंगे लाइव इवेंट्स में।
As we are in the low visibility region of the flight path, we take you to the discussion room where the key personnel connected with the Aditya L1 will enlighten more on the payloads and details. Over to discussion room.
Welcome viewers. After India has made history with the Chandrayaan-3 moon launch, it has now set its eyes on the sun. These scientific breakthroughs back to back are like feathers on our country's hat.
Range operation director.
In fact, these celestial bodies are very important and are considered as sacred bodies in multiple global religions. The sun is the central body of our solar system. The world revolves around it, and it is a source of energy for all planets, including the Earth. Today, I'm joined by all the scientists who have played behind the scenes to make this project a grand success. And I'm Srinidhi, reaching out to you from the Satish Dhawan Space Center, Sriharikota. And today we'll be discussing about the impact and the benefits of the Aditya L1 space mission. So today we are joined by Dr. Anil Bharatwaj, Director of PRL, Dr. Professor Annapurni Subramanian, Director of Indian Institute of Astrophysics, Dr. Sankara Subramanian, Principal Scientist of Aditya L1 mission, Dr. Durgesh Tripati, PI of SUIT, Dr. Dipankar Banerjee, Director of IRIS, Nainital.
Dr. Srimati Kesan, founder and CEO of Space Kids India, and my colleague Pallav Bagla with me in the studio. Dr. Kesan, a huge mission, a lot of excitement with this as well. We're still fully trying to analyze this mission and see if the Aditya mission is headed in the right direction, if all of the parameters have been met. We'll get more detail on that in a little while. But are you very enthused by this and what this promises as a science project?
Absolutely, absolutely. It's a scientific marvel, I should say. In fact, we have landed on the moon. The mission to moon is a critical one, but according to me, I would rate that going to the sun is even more critical. The analysis, the mathematics behind, reaching 1.5 million kilometers is, I think, absolutely brilliant that our scientists have put through, because the structures, we know how, being on Earth, we find it so difficult. Year on year, the temperature is rising, and to go 1.5 kilometers close to the sun, it is going to be absolutely critical. And the components that we have used, the material science plays a very, very important role here. So the structures that we have designed to actually keep up to the temperatures and radiations, I think it's a marvel, scientific marvel, I should say.
It is indeed a scientific marvel. Pallav, telemetry is important now. Where is this being tracked presently?
Oh, right now, see, people should not feel that the mission is accomplished. The mission is still on. It's a 63-minute mission. Right now, the rocket is not visible, so it's still performing its task in a coasting phase, which is why ISRO and all of us have gone down to some discussions. The rocket is continuing to do its performance. At 12:53 is when the satellite separates from the Polar Satellite Launch Vehicle and gets into its own orbit. So there is an ongoing mission. It is still not over. So the launch was successful so far. The mission has gone off very well, but it's in the coasting phase, which is a quiet phase. And then ultimately they will get back to the stage where it will be reignited, and then finally the separation. So it's a very important mission, like Dr. Kesan was saying. It's India's first space-based solar observatory, very important for the world, very important for India. And so far, the launch has been very good. The stages of the rocket have performed as they had been designed. The Polar Satellite Launch Vehicle is a workhorse rocket of India, and on this 59th mission, it has done so far so good.
It has indeed. So, Pallav, what are the next goals as far as the timeline that you were looking at right now is concerned, as far as the rocket is concerned?
See, the rocket is still in a coasting phase, so that means there is no thrust being given to the rocket. It is still flying in space, and then it will be reignited, and then the separation happens, and then there would be a passivation phase of the last stage. So 12:53 is the big moment, and then we have to wait and watch whether it gets a very accurate orbit, the precise orbit which ISRO is targeting. PSLV is well known for giving very well known for giving correct, precise orbits. If it gets a precise orbit, it has enough fuel and it can last a long time. Right now, the Aditya L1 mission is expected to last 5 years, but if there is enough fuel on board, it can last a lot longer. This is India's second observatory in space. We had AstroSat, which has lasted so much longer than its designed life. And that is what is expected of Aditya L1.
And if it's not in the ideal orbit, it can be made, it can be adjusted to the ideal orbit, but that means extra consumption of fuel on board.
Oh, that's right. There is a lot of, the liquid propulsion engine on the satellite will do a lot of work when it's being pushed from the Earth towards the sun, and then it has to work for almost 4 months, because it's not once it's put in the Earth orbit, the mission is not over. Beyond that, it reaches the halo orbit at L1 only 4 months later. So that's a long time, and the whole propulsion system needs to work. And if you have a correct orbit insertion on Earth, then you save so much more fuel on satellite, which increases the life of the scientific robotic satellite, which is Aditya L1.
Pallav, just in terms of what we saw a few moments back, and now we've got, scientists and astronomers tweeting about it. PSLV's stage 3 looks to have aimed a tad high. In other words, it was just a little higher compared to the plot of where the ideal situation should have been. But there's something called a tolerance level, right? It needs to be within a certain tolerance threshold. So that's something we need to keep our eye out for. It just appears to be slightly above its ideal chosen path.
That's correct. The plot was a little higher, but that's a coasting phase, and hopefully the closed loop guidance system will bring it where it's supposed to be. And continuously from the mission control room, we kept hearing that all stages performing normal, mission going normal. So one should not be unduly worried about that. I'm sure the onboard computers will correct whatever deviation has happened, if it has happened, but it could also be telemetry issues, because there are areas where there is a blind spot, and if that is the case, then it's a telemetry issue. But also there are corrections which can happen, and Dr. Kesan's team works a lot on some of this, and they have very young people doing some of the nice satellites, and also finally looking at some rockets also. So she may have some more insight on this.
Do you have any insight on this? Because it seems that while the PS4 liquid fourth stage, we don't know what the status there is, because it's out of telemetry range right now. We're presuming that it's functioning all right. But the third stage looks to have aimed a tad high. I mean, that's what some scientists and astronomers are saying.
Yeah, generally, slight deviation also perturbs, during a launch. We feel that probably this will go out of the trajectory. But I think, it is not a huge deviation as far as what we've been reading as of now, what we've been getting data. So I think this will be automatically adjusted. So I don't think, we should be really perturbed about this whole thing.
Okay. All right. We'll come back to all of you in just a few moments. We need to take a short break, but Aditya has, the mission is well underway now. The PSLV rocket has blasted off. We'll continue to track all the details. We do expect statements from ISRO as well in the next little while. For now, this short break.
Rashi school. From breaking news to in-depth analysis,
covering the latest developments
across politics, business and technology, bringing you stories that shape our nation and the world. When there's too much talking but very little being said, too many voices but hardly any being heard, you turn to a show that puts you front and center. A show that headlines the stories of the people, by the people, for the people.
From breaking news to in-depth analysis,
covering the latest developments
across politics, business and technology, bringing you stories that shape our nation and the world.
When it comes to sports, we set the ball rolling.
Because we have our eyes on the ball.
Because we want to get you the best.
Latest updates,
top interviews,
and analysis
from around the globe.
India has more gold than the World Bank reserves. And yet, we have won only 60 grams of gold in the Olympics. A total of just 10 gold medals in the last 123 years. Meet Neha Agarwal Sharma, who is working to change that. Once an Olympian herself, Neha's fighting spirit and unwavering dedication led her to stand on the world's grandest stage, representing India with pride and grace. But Neha's story didn't just end with her athletic career. Instead, it marked a new chapter. A chapter committed to empowering a generation of Indian athletes to claim their rightful place atop the Olympic podium.
We have a surprise for you. We're going to ask a bunch of you some special questions, and every correct answer is going to reveal what our surprise is.
I don't know. Satya Nadella?
Jeff Bezos. Bill Gates, probably.
Nehru Place. Saket.
Saket.
Mumbai.
Technical Guruji.
Tech Guruji. Technical Guruji.
Technical Guruji.
चलिए शुरू करते हैं.
My name is Captain Raghu Raman, and I have been fortunate to have had a career that has spanned 3 different domains. Whether it was the authoritarian style of leadership in the armed forces, or the mostly incentive-driven environment of the corporates, or the process-driven style of the government, I found that there were some principles of leadership that are present in all the environments. And these valuable lessons of leadership can be learned from literally thousands of leaders who are all around us. And we will meet them all on Wisdom of Leaders.
That was fast, right? But tech is evolving even quicker than our abilities to adapt. And that's how I like to roll. Technology तो आप सभी के पास है, but what you need is everything else. मेरा नाम है गौरव और अब मैं आ गया हूँ NDTV नेटवर्क पे हर रोज हर हफ्ते अब आपके और पास. Go beyond the now.
I think I was a big India believer. To me, it mattered a lot that why isn't India winning, right? If we would win medals in any other sport, I would cry. In my personal journey, that I knew that I could have been a better athlete. So I said that my life would be better served if I could help the next generation and basically ensure that the mistakes that were made during our career are not repeated in the next generation. It takes just 6 grams of gold to lift the worth of a nation.
NDTV for news you can trust. No sensationalism, no ugly debates, no agenda. We strive to be transparent and unbiased in our reporting so you can get news that you can rely on.
Welcome back. We're looking at the Aditya mission. Let's just return to the Indian Space Research Organization and the live feed coming in from Mission Control.
Looking at a small satellite program, and then Professor U.R. Rao suddenly came up with this idea, why are we taking baby steps? We should think big. We should go to much longer distance. And then this opportunity came in, the Lagrangian 1 mission. The entire country, all the scientific institution got very much highly motivated. There are multiple payloads were then proposed. So eventually now we have a Lagrangian 1 observatory class mission. And as you heard from my colleagues, that it is a multi-wavelength observatory. So that's very important to have the shorter wavelength coverage from the space. And in addition, the ground-based observations are also important. So a combination of the ground-based telescope and the space-based platform is very, very important. And since you asked about the question about the, how Aditya in the overall heliophysics research within the international scenario, we only have 3 spacecraft around Lagrangian 1 point primarily from NASA and ESA. So I think again this is a fantastic achievement from India. If you could reach L1 with the full observatory class mission, it will really open a new window altogether. So I think this is a great opportunity, and we are all looking forward. And as I mentioned, probably we'll request that, a better ground-based facility. We have already projected a National Large Solar Telescope project from the ground. I think this is now high time we have a very nice ground-based telescope also to complement the capabilities of Aditya L1.
Thank you very much, sir. Indeed, it's a very great opportunity. And now we move on to Dr. Vipin K. Yadav. So you're in charge of the magnetometer. What is the contribution of magnetometer to Aditya program?
You see, the magnetic field measurements are very crucial in space, and especially at L1 point. What we are going to measure with magnetometer is the interplanetary magnetic field that is coming all the way from Sun and towards the Earth. So typically these values at L1 point are around 5 to 10 nanotesla. But these values increases whenever there is an extreme solar event, such as the coronal mass ejection or say solar magnetic storms. Now these events are crucial to monitor the near Earth space weather, because these can have an effect on the life on Earth. If you remember Quebec, there was an event when the power lines were snapped a few years ago. That was because of an extreme solar event. So to keep an eye on the surroundings of Earth, we need these measurements, and apart from that, for solar wind observations also, these measurements will be crucial. Thank you.
Thank you very much, sir. So now we move on to Dr. Anuj Nandi. So what is the importance of solar flares and the impact in heliospheres? And how does Aditya L1 contribute to all of this?
Good afternoon, viewers. As my colleagues already pointed out the importance of this mission and the instruments about. So the thing is, as you know, that solar flares are the energetic and explosive energy release in few seconds to minutes time scale, and it is order of 10 to 27 arcs to 10 to 32 arcs. Now the thing is, these solar flares, why it is important, as because the solar flares actually tells the dynamics and activity in the sun. So the thing is, there are two unique instruments built by URO Satellite Center that is going to cover the solar flares from 1 keV to extremely high energy, about 200 keV. And we know that visible sun is only 6000 degree Kelvin temperature, whereas the outer surface of the sun is million degree Kelvin. So the thing is, why there is disparity? So I think these two instruments, along with the other two instruments, VLC and SUIT, we are going to address this $1 million questions, as well as why there is difference. Thank you.
Thank you very much, sir. And now I'd like to go back to Dr. Anil Bharadwaj. So there are many satellites that are sent to the space by other nations. So what makes Aditya L1 different from these satellites?
Well, that's a very good question, because first of all, let me again tell you that India will be the third, or ISRO will be the third space agency to have a mission at L1 point. And I just mentioned that it is multi-wavelength, multi-instrument, and multi-direction, and it measures particle, field, and radiations. So you don't have such kind of satellites existing at L1 point so far and currently. That makes Aditya L1 absolutely unique, because we are going to measure remotely, in situ, and particles and fields. I was also mentioning about multi-direction, and that is coming from the aspects payload, which stands for Aditya Solar Wind Particle Experiments. And this is going to measure particles ranging from 100 EVs going to several MeVs, which is essential for us to know, because when the CMEs are happening or the sun is quite angry, the plasma which is coming out from the sun ranges from several EVs to several MeVs. And therefore, we should know in what direction the plasma is coming, and whether the plasma is getting accelerated in between when it comes from sun towards earth. And therefore, there is a multi-direction information which is available from the aspects payload, because it consists of two sensors, SWIS and STEP, essentially giving you in two different energy bands, and therefore we'll be able to quantify the CME, CIRs, and all the process which is happening on the sun, which gives out coronal mass ejections. Thank you.
Thank you very much, sir, for your remarks. And now finally we move on to the principal scientist, Dr. Sankara Subramaniam. So how does the Indian science community seek to capitalize on ISRO's space capabilities, especially these observatory missions like Astrostat and Aditya L1?
Yeah. So now ISRO has established that it has a capability to send observatory class missions anywhere in the interplanetary medium. ISRO also is developing capability for small satellite missions like a nanosat, CubeSat, as well as the small satellite capability. And that is something which especially a heliophysics community could utilize it, because we can, at a low cost, we can launch many more such instruments which are essential for heliophysics community here in India. So, and also the bigger mission takes its own life cycle, because it requires technologies to be developed for a bigger missions. So in between these big missions, if we capitalize on these small satellite missions, and that will enhances the science capability of our country to the next level. And as you know, the science and technologies are always synergized. As the technology improves, your science improves. When I started my career in solar physics, I started with a photospheric magnetic field. Now we are in a position where we can do coronal magnetic field with Aditya L1, which was not feasible when I was doing my PhD. So similarly, as we move on and as the technology starts to improve, we would be able to generate much more capable instruments, much more compact instruments, which will enable us to do much more science than what we can currently do. So we look forward to capitalize on ISRO's capabilities, both at the large scale as well as at the small scale instruments, and also its capability for developing new technologies in the near future.
Thank you very much, sir. That was very interesting. And to end this, I have a last question to Dr. Dipankar Banerjee. And it's about what kinds of outreach is possible through this launch to energize the scientific community?
This is a very, very important question, and we are proud to be Indian now after the Chandrayaan success. I think it's just not the students, it's the entire country is excited. And we got this opportunity to now travel towards Sun. So it is very important that
Hospitalized. 23 years of the big fight. This show is not just an ordinary debate show, but it is a responsibility in service of our viewers.
NDTV for news you can trust. No sensationalism, no ugly debates, no agenda. We strive to be transparent and unbiased in our reporting so you can get news that you can rely on.
In a world with rapidly shifting power dynamics, India is emerging as a global power. With its new standing, how do Indians view the world?
A debate has many facets, perhaps no one right answer. Left, right and center. Conversations that get to the core of the debate.
In a world filled with noise, we bring you news that you can rely on with accuracy and integrity, because at NDTV, trust is everything.
The NDTV News Network
that informs,
inspires
and illuminates. Watch every side of the story here on NDTV,
because the only side we're on is yours. Business news can sound incomprehensible, unnerving, unrelatable. But how does it impact you? We deconstruct complex business news and ideas by talking directly to the leaders who shape the economy. We are serious about business.
We have a surprise for you. We're going to ask a bunch of you some special questions, and every correct answer is going to reveal what our surprise is.
I don't know. Satya
Jeff Bezos. Bill Gates probably.
Nehru Place. Saket.
Saket.
Mumbai.
Technical Guruji.
Tech Guruji. Technical Guruji.
Technical Guruji.
चलिए शुरू करते हैं. That was fast, right? But tech is evolving even quicker than our abilities to adapt, and that's how I like to roll. Technology तो आप सभी के पास है, but what you need is everything else. मेरा नाम है गौरव और अब मैं आ गया हूँ NDTV नेटवर्क पे हर रोज हर हफ्ते अब आपके और पास। Go beyond the now.
When there's too much talking but very little being said, too many voices but hardly any being heard, you turn to a show that puts you front and center. A show that headlines the stories of the people, by the people, for the people. From breaking news to in-depth analysis, covering the latest developments across politics, business and technology, bringing you stories that shape our nation and the world. When there's too much talking but very little being said, too many voices but hardly any being heard, you turn to a show that puts you front and center. A show that headlines the stories of the people, by the people, for the people. From breaking news to in-depth analysis, covering the latest developments across politics, business and technology, bringing you stories that shape our nation and the world.
When it comes to sports, we set the ball rolling.
Because we have our eyes on the ball.
Because we want to get you the best.
Latest updates,
Top interviews
and analysis
from around the globe.
India has more gold than the World Bank reserves. And yet we...
soon. But this is where we are presently. This
कुछ ही
is
क्षणों में
time versus altitude.
चतुर्थ चरण के पुनः प्रज्वलन को देखेंगे।
In the past 26 minutes or so, the ground trace for the flight was being updated by extrapolation.
Four-stage engine started for band 2.
यहाँ अभी रेंज ऑपरेशन डायरेक्टर ने इसकी पुष्टि की। चतुर्थ चरण का प्रज्वलन शुरू हो चुका है। यह पुनः प्रज्वलन है PS4 का कोस्टिंग फेज के पश्चात। यह वास्तविक समय पे हमें यहाँ आंकड़े उपलब्ध हो रहे हैं क्रूज स्टेशन से।
Very happy piece of news here.
Normal.
Range Operations Director has confirmed the second burn commencement for the PS4 stage. Around 14 more minutes to go for the spacecraft injection.
Of our viewers, what you're actually seeing, mission control at Sriharikota, the PSLV C-57 Aditya L1 mission. The blast-off took place at 11:50. It is a relatively long mission before Aditya is injected into space. Aditya is the observatory which is going to be studying the sun, which is going to be released in space. It's going to be in orbit of the Earth initially. It's then going to be pushed gently to a spot in space called the Lagrange point. And it's going to take 4 months approximately to get to the Lagrange point. That is when the gravity, the influence of the gravity of the Earth is diminished and the influence of the gravity of the moon is not strong enough. So it is an ideal spot where a particular orbit will be initiated, and that will ensure that Aditya, the satellite, is actually pointed in the direction of the sun 365 days a year for several years. In fact, the mission life is at least 5 years, and data can then be collected. But we are still relatively early, as we, so to speak. Aditya will be released. The payload, the fairings will open up. In fact, the fairing has already opened up, but the spacecraft itself, Aditya, will need to be separated and then injected into Earth orbit to begin with. That's about 11 odd minutes away from now. Let's just listen in to what ISRO is saying.
रॉकेट का इसमें 2.5 टन के नोदक का इस्तेमाल हो रहा है। यह तरल नोदक हैं। इसमें 2 इंजन लगे होते हैं, हर एक 7.33 किलो न्यूटन का प्रणोद उत्पन्न करता है। इस तरह कुल प्रणोद 14.6 किलो न्यूटन का होता है।
प्लस 55 मिनट्स।
इस प्रज्वलन काल में इसे 472 सेकंड तक प्रज्वलित रखा जाएगा। वरिष्ठ गणमान्य व्यक्ति यहाँ उपस्थित हैं।
We are close to 55 minutes 30 seconds past the launch. PS4 stage currently burning for the second time.
Stage performance normal.
Intended trajectory closely matching the prediction. Presently, the shipborne terminal is acquiring the signal. Few seconds later, there will be another no visibility phase before Koru starts to acquire signal.
जी अभी द्वितीय बर्न चालू है PS4 स्टेज का। अभी कुछ 200 और सेकेंड जलकर यह शांत हो जाएगा। सूर्य एक बड़ा और हमेशा से एक समीप का सितारा रहा है हमारे लिए। असल में यह गर्म आग का गोला है जो अनगिनत हाइड्रोजन एटम्स के फ्यूजन रिएक्शन से ऊर्जा प्राप्त करता है और इस ऊर्जा से इस सौर मंडल को एक परिवार की भांति समेटे हुए है। पृथ्वी से सूर्य की दूरी लगभग 150 मिलियन किलोमीटर है। सूर्य ही हमारी ऊर्जा स्रोत है और इस जीवन जो हम जानते हैं उसका भी स्रोत है।
Loss of signal for shipborne terminal. The next telemetry station is Kuru. The telemetry signal break will be approximately 205 seconds. During this non-visibility period, ground trace and flight parameters will not be updated.
यान फिर से अंतर्दृष्टि हो चुका है, हमारे ट्रैकिंग रेंज से बाहर है। अगला ट्रैकिंग स्टेशन कुरु स्थित फ्रेंच गयाना स्थित कुरु स्टेशन से हमें आंकड़े उपलब्ध होंगे कुछ ही समय में।
After being injected into the space, the Aditya L1 will not travel directly to the L1 point. Transfer maneuvers will be performed to position the spacecraft in a halo orbit. Aditya L1 will first be made to perform maneuvers in Earth orbit. Adjustments will be made in its orbital parameters. After ascertaining the normalcy of the craft, its systems, payloads, and the orbital parameters, burn to exit Earth's sphere of influence will be initiated. After exit from SOI, the cruise phase will start and subsequently the spacecraft will be injected into a large halo orbit along L1. The total travel time from launch to L1 will take about 4 months for Aditya L1.
इस दौरान आइए आपको अवगत करा दें आदित्य L1 के मुख्य उद्देश्य से। आदित्य L1 मिशन का मुख्य उद्देश्य है सौर गतिविधियों के विभिन्न पहलुओं में महत्वपूर्ण जानकारियां उपलब्ध कराना और इन गतिविधियों का अंतरिक्ष मौसम के असर का अध्ययन करना। इस कार्य के लिए इसमें 7 भार लगे हुए हैं जिनकी मदद से आदित्य L1 फोटोस्फीयर, क्रोमोस्फीयर और सूर्य के बाहरी परत के विभिन्न वेवलेंथ में प्रेक्षण कर सकेगा। विशेष वैज्ञानिक उद्देश्य इस प्रकार हैं: सूर्य के ऊपरी परत जिसे हम कोरोना के नाम से जानते हैं, इसके गतिकी का अध्ययन करना, क्रोमोस्फीयर और कोरोनल तापमान, आंशिक रूप से आयनिक प्लाज्मा की भौतिकी, कोरोनल मास इजेक्शन की शुरुआत और फ्लेयर्स का अध्ययन, सूर्य के कण की गतिशीलता के अध्ययन के लिए आंखें प्रदान करना और यथास्थिति कण और प्लाज्मा वातावरण के परीक्षण करना।
+1 hour.
वर्तमान में आरओडी ने घोषणा की अब चतुर्थ चरण को बंद कर दिया गया है, अब उसका थ्रस्ट कट ऑफ कर दिया गया है और वह बंद हो चुका है और इसकी भी पुष्टि हो चुकी है कि आदित्य L1 के अंतक्षेपण की स्थितियां प्राप्त की जा चुकी हैं।
We are now eagerly awaiting the injection of the satellite as we have the confirmation from the Range Operations Director that the thrust cutoff for 4th stage of PSLV has been achieved. We are 1 hour into the flight.
कुछ ही क्षणों में क्रूज स्थित ग्राउंड स्टेशन से इसकी पुष्टि की जाएगी।
Highly anticipated event next is the separation event of Aditya L1 spacecraft.
यान अपने निर्धारित कक्षा की ओर कुछ ही क्षणों में इसकी पुष्टि होनी बाकी है। यान से अंतरिक्ष यान आदित्य L1 का सफलतापूर्ण अंतक्षेपण अभी बाकी है।
For Aditya L1, ISRO has developed advanced flight dynamic software to obtain past trajectory data from tracking, apply mathematical computation to calculate present and future location of the spacecraft in a process known as orbit determination. But the correct orbital parameters at the time of injection are of prime importance.
अब तक कुल 22 सौर मिशनों को नासा, ईसा, जर्मन
Aditya L1 satellite separated.
और जिसका इंतजार था वह पल आ चुका है, इसकी पुष्टि कर दी गई है। आदित्य
L1 mission accomplished, handing over to mission director.
And we have a confirmation of Aditya L1 separation. The mission has been accomplished.
Yeah.
C-57 has injected Aditya L1 satellite into the desired intermediate orbit. PSLV C-57 Aditya L1 mission is accomplished.
आदित्य L1 को पूर्ण परिशुद्धता से इसके निर्धारित कक्षा में स्थापित कर दिया गया है।
At the moment,
इसके बाद
Aditya L1 has been successfully launched. Dr. Mr. Somnath over there, the ISRO chairperson, is going to be addressing the media in a few moments from now. So far, the mission, successful liftoff, correct injection of the satellite into the Earth orbit before it's ultimately pushed to its location. The Minister Jitendra Singh with him. This is a resounding success as far as today's developments. There were a couple of nervous moments, but it's been picked up successfully in tracking stations everywhere. Let's listen in.
Congratulations. The Aditya L1 spacecraft has been injected in an elliptical orbit of 235 by 19,500 kilometers, which is intended very precisely by the PSLV, very unique mission mode here, with the upper stage of the PSLV taking 2-burn sequence for injecting the primary satellite for the first time. So I want to congratulate PSLV for such a very different mission approach today to do this mission of Aditya L1 to put it in the right orbit. Now, from now, the Aditya L1 will take its journey after some Earth maneuvers. It will start its journey to the L1 point, a very long journey of almost 125 days. So let us wish all the very best to Aditya spacecraft for its long journey and being put around the halo orbit of L1. So with me, the mission executives are there. Mr. Biju, the mission director, and Nigar Shahji, the director of the satellite project. So let them join me. Our Honorable Minister of State for Science, Technology and Space is here, Dr. Jitendra Singh. So I request him to speak a few words.
Congratulations, India. And congratulations, ISRO. And while the whole world watched this with bated breath, it is indeed a sunshine moment for India. Thank you, Honorable Prime Minister Narendra Modi ji, for making this happen by opening up new vistas for India's space sector and telling us that sky is not the limit. Thanks also, Honorable PM, for giving us the confidence, the courage and the conviction to reach out to the stars and to discover the mysteries of universe beyond. And thanks also for making us realize the enormous potential of our space fraternity. Ladies and gentlemen, Indian scientists had been working, toiling day and night for years and years together, but now comes the moment of vindication, the moment of redeeming the pledge to the nation. And coming close on the heels of successful Chandrayaan-3 landing, the successful launch of Aditya L1 is also a testimony to the whole of science and a whole of nation approach which we have sought to adopt in our work culture. While ISRO is credited in executing this mission, the science institutes across the country have come forward to contribute in one form or the other, in small measure or big, to this mission. To name a few, the Indian Institute of Astrophysics, Bengaluru, the National Aerospace Laboratories, the Tata Institute of Fundamental Research, Mumbai, the Nijri NGRI, Nagpur, the IIT Kharagpur, IIT Madras, IIT Delhi, IIT Mumbai, and the list is too long. But that, having said that, gives me the confidence to say that this day, the 2nd of September 2023, is a day of reckoning when we move on into the next 25 years of Amrit Kal, and Mother India pledges with the collective will and collective effort of our 140 crore children to reach and occupy the place of pride on the world pedestal. Congratulations once again, Chairman Somanath, the entire ISRO team, and the entire countrymen.
Thank you. May I
family floater.
We have a surprise for you. We're going to ask a bunch of you some special questions, and every correct answer is going to reveal what our surprise is.
I don't know. Satya
Jeff Bezos. Bill Gates probably.
Nehru Place. Saket.
Saket.
Mumbai.
Technical Guruji.
Tech Guruji. Technical Guruji.
Technical Guruji.
चलिए शुरू करते हैं।
My name is Captain Raghu Raman, and I have been fortunate to have had a career that has spanned 3 different domains. Whether it was the authoritarian style of leadership in the armed forces or the most
Director URSC, former Director URSC, and all the Center Directors for their support and guidance for making this mission possible. And my thanks are due to my project team and all the project executives across the center, payload teams, especially the teams from the IAA and IUCA, for the relentless effort in building the payload as well as the spacecraft. And my special thanks to the expert committee who have been guiding all through the entire project life cycle. And I thank all the industrial partners and the entire URSC team for their invaluable contribution. And I feel really honored and privileged to be part of this mission. And at this juncture, I would like to remember Professor U.R. Rao, who sowed the seed for this mission, and looking forward for a successful halo orbiting session and further great science output from the Aditya L1 mission. Thank you all.
Sri Biju, the mission director and the project director of PSLV.
Good afternoon to all. My big salute to all of you for achieving this wonderful mission of Aditya. We have injected Aditya in its intermediate orbit. PSLV in its 59th mission has successfully accomplished injecting Aditya L1 in its intermediate orbit. It's all because of the dedicated effort of all of you. The challenging requirements given by satellite team was indeed very it was very challenging to meet the orbital requirements. We have gone for a new mission design strategy. We have gone through numerous simulations to validate this, and that is the proof that you are having now. I take this opportunity to thank each and every one of you for achieving this wonderful mission. I take this opportunity to thank all my review forums, chairman and members of all review forums, and our industry partners for giving high reliable systems for PSLV, and all our family members. With this, our capability of PSLV has increased manifold to venture into new missions, to new and challenging missions. I take this opportunity to thank my project team led by our Sri M.J. Lal as well as Damodaran, Vehicle Director and Associate Vehicle Director, in leading the entire campaign. I wish our satellite team an excellent time ahead for completing all the operations and completing all scientific objectives they have envisaged. Thank you all. Thank you very much.
Thank you everybody for spending your time watching this mission and also supporting us and congratulating us, and we joined the entire country. We are very proud of the fact that we could do this mission, Aditya L1 mission, just following the Chandrayaan 3 activities, and all of you are aware that the lander and the rover are still functioning, and our team is with the scientific instruments doing a lot of work now. And the good news is that the rover has moved almost 100 meters from the lander, and we are going to start the process of making both of them sleep in the coming 1 or 2 days, because it has to withstand the night. So until we hear about them later, so I would like to say big thanks to each one of you for the support and encouragement and blessings that you are giving to us for continuing the work of building the very strong space infrastructure and capability for India, and which will be becoming one of the strong pillars of science and technology for this nation. And thank you so much for the contributions once again, and wish you all the best for meeting you for next mission from Satish Dhawan Space Center.